Hello all. Welcome to the first video of this particular course, where in this particular video, I will start with introducing about generative AI. And eventually in our next upcoming videos, you'll be seeing about how to work with generative AI and agentic AI systems. Okay. So first, before starting understanding what is generative AI, first we'll start with understanding what exactly is AI, correct? So in general, AI stands for, artificial intelligence, right? Now, what is artificial intelligence in general? So first, we'll understand what is intelligence. What is intelligence? Intelligence is nothing but the ability to take decisions, right? And we human as are intelligent enough to do a lot of things, right? Right? Like we take decisions, we are able to do some kind of visual understanding, correct? We are able to speak to each other in our natural language, right? We are able to communicate basically, correct? Communicate in natural language. So we have these kind of abilities, correct? Now, when you say artificial, what is artificial? Which is obviously not natural, which is, man-made, man-made, correct? Means more clearly, I can say it's a machine. So in general, artificial intelligence is something where you are trying to make this machine intelligent, right? So whatever we are capable of, whatever we are able to do, like we are able to take decisions, we are able to see something in the surroundings and identify that, and we're able to communicate, right? So making a machine intelligent, right? Making a machine think like human and replicating the human brain is basically the AI, right? It's basically AI, okay? So this AI was introduced, was first, the term AI was very, very long back ago. It's around 1957 or something like that. So in the journey of entire AI, there were a lot of approaches followed by different people, different researchers in order to make machine intelligent. And that was, started with statistics, correct, where the machine, where we were trying to understand the data through graphs, through various analysis, and we were trying to, you know, do some kind of data understanding, pattern understanding, and we were trying to work with data. Eventually, this led to another branch, one branch called as, machine learning, right? This was, the first step of AI, I can say, where it was more focused on statistical and mathematical algorithms. Like, for example, we have something like, uh, linear regression or logistic regression, right? These kind of algorithms, where it was completely the mathematical based, where, decision tree, random forest, these kind of algorithms, right? Or SVM. So these kind of algorithms were involved in machine learning, where it was completely based out of statistical and mathematical approaches, right? Maybe you might used in your when you were in school or mathematics, when you're learning about mathematics, you might learned about this equation, right? Y is equal to mx plus c, or you might learned about something like entropy, some concept like entropy or something like that, right? So these algorithms, whatever we are having, these algorithms were mathematical algorithms, and these algorithms were designed in such a way that it was able to predict something, right? So the idea of machine learning was given a data, right? So you will basically have a data, right? You have a data, and data can be a image, or data can be a video, or data can be an audio. It can be anything again, or it can be a text data, right? Or it can be a tabular data. Okay. So when you have this kind of data, the idea was we want our machine, we want our machine to read this data, to understand the patterns in this data, and do some kind of prediction, do some kind of prediction. And that is where the concept of machine learning started with, right? Where we first make the data learn, make the machine learn from this data using these algorithms, right? Whatever algorithms I wrote here, using these algorithms will make the machine learn from these patterns. And you can do some kind of prediction. For example, it could be kind of sales prediction, sales predicting of sales, upcoming next month sales of a company, or it could be cost prediction of something, right? It could be cost prediction, or if you take in healthcare, maybe diabetes prediction, whether the person has or not. Given a person data, historical data of health, maybe you'll try to predict whether the person is prone to diabetes, or whether the person will have any kind of diabetes issues or not. So these kind of things people were doing using machine learning, companies were using machine learning, right? So eventually the complexity of the use cases increased, right? So here we were mainly focused on in machine learning, we were mainly focused on tabular data. But right, in this world, it's lots of unstructured data where you have images, we have video or audio. So for these kind of data, for these kind of complex use cases, machine learning was not enough. That is where the idea of deep learning came into the picture. That is the next level of machine learning. You can see the advanced machine learning, which is deep learning, obviously. So in the concept of deep learning, it's again advancement of machine learning, but it was in a slightly different way. So in deep learning, basically we have something called as neural networks, right? Which again takes your data, learn patterns, learn patterns from the data, and try to again do the prediction. Here also the task was prediction. Given a data, we have to do some kind of predictions. And typical neural network will look something like this. Let me show an example. It looks something like this. A typical neural network will be something like this, where you can see, right, there are a lot of circles. So this particular neural network, guys, it was inspired from the human brain. So we know, right, AI is all about replicating the human brain. So this neural network was inspired from the human brain. If you see these circles, right, each circle is considered like a neuron. That is where the term called as neural network came into the picture, where neural stands for the neuron, the artificial neuron, which we also have millions of neurons in our brain, right? And these neurons communicate with each other, and that is where we can make decisions, and we can remember anything, and we can recognize anything. So in the same way, in the neural network, basically we are trying to replicate this neurons architecture, and network is nothing but your connections, right? So in deep learning, what we do is we build this kind of neural networks where each neuron is learning something from the data. Again, the interesting thing here is, again, in each neuron, it's again a mathematical algorithm itself. Each neuron is again a mathematical system. So it's like advancement of machine learning. So you can see each neuron is again one ML algorithm, you can assume. But here we are not just using one single simple ML algorithm, but we are using a group of patterns, a group of machine learning algorithms, which is learning the patterns in a different manner, a different way. So you can imagine, right? We're having a different algorithms, different brains, and they communicate with each other, and finally, helps us to do some prediction, helps us to do some prediction. Now, why do we need a deep learning algorithms? Is, see, machine learning is up to some level, it works. But when you go to more complex use cases, like something like, image recognition, if you want to identify what is in an image, okay, or if you want to do some kind of text based analysis, deep level analysis, so in that case machine learning algorithms are not that great. So that is where the concept of deep learning came. And here the advantage of deep learning is you can go deeper and deeper. Like if you see, these neurons are not fixed number, you can add more and more neurons. The more you add the neurons, you get more better accuracy and more better performance. So that is the idea of the deep learning. So you can work with complex use cases here, like image classification. You see this face recognition application, right? So these kind of applications, face recognition applications, and you see the object detection based applications. So these kind of applications you can actually work using deep learning, or text-based applications. Deep learning will be helping us, right? So that is where the AI, took off. Once deep learning came, it was, evolved a lot, and a lot of companies started implementing a lot of use cases in deep learning related to, images. It might be related to text data, natural language data. It might be okay. Then the next era came. That is where they want to advance the deep learning, and in the deep learning itself, few algorithms came into the picture, like CNN. which is specifically for image, okay, which were designed for images. And then we have the algorithms like RNNs and LSTMs. And these algorithms were again specialized neural networks specifically for the text data. It will work really great for the text data. When you say text data, like it's like a human spoken text or human written text, like our natural language, right? Human spoken text or human written text. It's like our natural language. Okay. So it's these were the algorithms for that, the RNNs and LSTMs. So these using these algorithms, we were working with advanced NLP based tasks like natural language based tasks, like predicting the next word. So if you remember early, during early 2018, 2017, Google launched Gmail. In Gmail, you can see a feature, right, where when you start writing an email, it was predicting the next word. So that is where next word prediction. That was a start, I can say. That was the start of generative AI. So next word prediction, or some kind of text sentiment analysis in your for identifying the sentiment. For example, if I say a text, you identify the sentiment, the machine identify the sentiment. It will be helping in the reviews analysis, right? So these kind of use cases people are working on. Then came one architecture which actually started and which was the start point of the generative AI. Actually, this is the I can say revolution in the AI, that is the transformer architecture. Okay, the transformer architecture. This is, I can say, transformer is like an advancement of deep learning, like how deep learning was advancement of machine learning. Transformer is again advancement of deep learning algorithm, where there was a problem in an RNN LSTMs, guys. RNN LSTMs were, first thing, they were a bit slow because we have to send only each word at once. So they were slow. And second one is they were not working that great for larger text. They were having issues with larger text, which with larger text, like if you give a paragraph of data, it was not that great. That is where this problem was solved using transformers. And in transformers, there were already some mechanism called as attention mechanism, right? And that was included in this transformers, which actually made the transformers better. So these transformer was introduced in 2017 by Google researchers, okay, by Google researchers, and that actually was the start point of the LLM models or the generative AI models you have seen. So let me show an example of how the transformer architecture looks. Okay, so this is how the transformer architecture looks, where you see this is basically called as encoder, this is called as decoder. Not to go deep into this because our main idea of this course is to understand the how to use LLMs and how to integrate LLMs and do applications on that. But yeah, this is just a start. Like will help you to understand how this works in the back end. Okay, so this is an example of this is how the transformer architecture looks, and this is like a start. And this was actually this transformer architecture was released in a research paper called as Attention is All You Need. Okay, if you search for attention is all you need in the Google, this is the first link you get where you will get this research paper. You can just, if you're interested, you can just go through this research paper where they introduced about the transformers and how transformer works in the back end. So these was the starting point of the this generative AI era. Okay, then once the transformers was released, people were exploring, companies were exploring about different algorithms like BERT came into the picture, which was working great for the text classification. T5 came into the picture. Then OpenAI started working on this transformers. Like they started working with transformers, and they released the GPT-1, GPT-2, right? These models, which is again the backend was transformer based. And then came the GPT-3, which was, made like completely was revolution in the market, right? It actually break the market, where from GPT-3 and GPT 3.5 was the first version of the chat GPT, correct? This was the first version of chat GPT. So from here, rest is history, right? The new era came into the picture, the new era of AI came into the picture. And from here, the new AI branch evolved, and that is called as generative AI, right? Where if you see in the earlier branches of AI, where we in machine learning or deep learning, It was all about given a data, it will do some prediction. Given a data, it will do some prediction. The task was just a prediction, right? Even in the CNNs also, you'll be giving an image, it will predict what is in the image. Or if you in CNN, in RNNs also, you'll just give a text, you'll predict what is the sentiment of the text or what is the next word. But here it is slightly different. In this generative AI, here, you'll have a Gen AI model, right? When you have a Gen AI model, it's all about you give something called as prompt, right? You give something called as prompt, or we can call it as input, and these models are responsible to generate content, not just prediction. They are actually doing generating the content, or we can say generating the data. Okay, it's not like prediction, but we are basically generating the data. Okay, that is the basic idea of that is the reason the name is called as the name. If you see, it is generative AI, generative, right? It is generating content, generating data. Again, your data can be anything. Data can be a image, data can be a video, data can be an audio, data can be a simple text, which current Gen AI models are doing from start. Of course, we are having image generation models, video generation models as well. So yeah, so data can be anything ultimately. So the idea of this generative models, generative AI models are just, you give a prompt or input and it will generate the content. Okay. So this was the start of generative AI, where it was mainly focused on generating the content. And the backend was obviously the transformer-based architecture. So eventually, once OpenAI started working on this, and once they released ChatGPT, then eventually the other companies also started working on this branch, and they have released their own models. For example, Anthropic released their Claude models, right? Claude models. Google released their Gemini models, which is basically again the LLM based. Again, the Microsoft released their Pi 3 models. So like that, every company, are started working on this. We have many open source and closed source LLMs, which is basically, that's how the generative AI came into the picture and it has evolved. Okay. Now, in this concept of generative AI, you'll be hearing a term called as LLMs a lot, right? You might already heard about it. If not, we'll just understand a basic about this. However, from the next video onwards, we'll be going deeper into LLMs and working with LLMs. But in short, LLMs are nothing but basically the full form is large language models. Large language models. Now, here, why they are called as large language models, why these are basically called as this means basically your large indicates high parameter model. High parameter model. When you say what is meant by high parameter, it means that, see, basically, guys, whenever your model is learning, when your machine is learning, there will be something called as parameters or some kind of numbers the machine will learn to do this kind of prediction or do some kind of content generation. So if you go back to a deep learning example, here you can see each neuron, right? Each circle is one parameter, you can assume, right? Each neuron is will be having one parameter, you can assume. Like that, there are a lot of parameters. We'll be having billions of parameters, millions of parameters here. So these parameters will be helping the model to learn and understand the data in the pattern, or like patterns in the data. Now, if you come to machine learning, the number of parameters were very few. The number of parameters were very few, like max 10, 15 parameters. Whereas when you come to deep learning, as I told you, can have n number of neurons, you can have some n number of neurons, depends upon the tax. Depending upon tax, people were using some millions of neurons, some up to some million max. But here, if you come to the generative AI, it's went to billion actually. If I say an example, GPT 3.5, which was the first ChatGPT version, was actually 175 billion parameter. 175 billion parameters means you can see how large it is, right? How huge it is. Means your model has to learn this many numbers, this many parameters to predict the content, to generate the content, right? So that is the reason it is called as large. It is very, very huge. And right now, this is a very old model that is 175 billion, but now we are in 600, 700, and also we are going to trillions as well. So yeah, that is the reason we say it as a large. And that is the reason they are very accurate and they're very strong enough. You can see the performance was is really good, right? Because of this number of parameters. And your language, because see, if you see the first model, which was generated by OpenAI, which was released by OpenAI, it was text-based model, right? It was you given a text, given a prompt, you get a text as output, prompt as output, correct? Text as output, right? Text as output. So that is the reason it is called as language. Even though now the current models which we are working on can generate images, can also understand images, but still these are called as language models because they start with the language. Again, here you have to give the prompt for this. So ultimately, you work with text data. That is the reason it is called as language. And model is nothing but the trained algorithm, right? That is the reason these are called as LLMs, which is large language model. Large is nothing but very huge in terms of number of parameters. You'll have so many parameters in it. Basically, these parameters are also called as weights, okay, which are the weights and biases, which is, which the model learns, and language is nothing but for the text and model, okay. So we'll go deeper and understand about LLMs in our next upcoming sessions. We'll be working with open source and closed source LLMs, but yeah, this LLMs terms will be hearing a lot, okay. Now, this is the idea of generative AI. So when you're working with generative AI, you will be working with LLMs a lot. They are like the brains, you can say. The LLMs are something which can think and which can generate content, correct? Now, the next upcoming, evolving and the next upcoming market where you see a lot of potential is the agentic AI, right? The agentic AI. So now, how is generative AI different from agentic AI? So you'll be I guess you might be hearing this agentic AI a lot in the market right now, and it's very popular right now. So what is different between agentic AI and generative AI? So let me explain. So now, if we talk about generative AI in Gen AI, if you see Gen AI, what happens? You'll have a LLM model, right? The large language model. And what is the goal of this large language model? Given a prompt, right? Given a prompt, the idea is to generate content, correct? Generate content. Very good. Now, for example, if I want to send an email, okay, imagine I want to send a email. Now, can a LLM model send an email? Maybe no, right? Obviously, correct. But if it can it generate? Yes. LLM model can generate an email. If I want, sorry, for example, if I want to, send an email to my boss, or I want to send an email to my employees, or I want to send an email to a client for regarding something, and I want to, LLM to help me in that. It can generate the content, right? It can generate the email, but can it send? No, right? It can only generate. So you have to manually copy and paste. So that is an example. Or if you want to do any kind of task, LLM cannot do it. It can just generate content. LLM is only for generating content. That is where the concept of agentic AI come into the picture. So agentic AI are something bit advanced where you can not only just generate content but do task. How? So in generative AI, in agentic AI, what happens is you'll be having something called as an agent. Okay, you'll be having something called as an agent, and this agent will have something called as tools. It will have something called as tools. It will be having something called as memory, right? You'll be having again the regular one, that is LLM. Okay. So what happens here in this agentic AI is you will actually here not input a prompt, but you will be inputting a task. Here in the agentic AI, you don't work with prompt, you will be working with a task. And the idea is this agent should do the task with help of the tools. Now here, what happens is this LLM will be acting like a brain. So you can imagine like this, guys. For example, you have your brain, okay? You have only your brain, but you don't have your hands or you don't have your legs. Can you do anything? No, right? With only brain, you cannot do anything. But with brain, if you're having your hands, your legs, your body, that is your tools for your brain to do any task. For example, you want to cook something, right? So imagine that recipe is in your brain, but without your hands and without the ingredients, without the tools, whatever you have there, you cannot cook, right? You cannot actually make it possible. So LLM is the same way. So LLM can only generate content, but it cannot do things. That is where the agentic or agent will come into the picture, where agent will use LLM as a brain to get what it has to do, and it will use the necessary tools, okay, which will basically do the task. So for example, imagine I want to send an email to a client. So in this case, what happens is agent first use LLM to generate generate the mail. And here you might have a tool called as send email. Maybe you might have create a tool called as send email, and it will use this tool to send actual email. So it is actually doing your task. And memory is to just understand what it has done in the past. Like how do we have memory to understand what we have done in the past? In the same way, the agent also will have the memory to understand what it has done. And finally, the result is the output, what the result of the task. So that is what the agentic AI. So agentic AI is all about using the LLMs as a brains to do a task, to perform a task. That is the main goal of agentic AI, which is advanced generative AI here. So here we are not just using the LLMs to generate content, but do specific tasks related to the our day-to-day task or anything it can be. So I'm just telling a very simple example, but you can imagine just you can do a lot of things, a lot of advanced things using this agentic AI. So this is a brief introduction about agentic AI, generative AI, guys, and of course the AI itself, that is machine learning and deep learning. So I hope you understood and got the basic idea of this. Uh, so this was just basic introduction. So in the next session, we'll focus on deeper into LLMs. We'll understand the different what is LLMs, and we'll be focusing on open source, closed source LLMs, and we'll do some hands-on on that. Okay. So let's meet in the next video then. Thank you guys. Thank you.